Okay, today I'm going to solve this inequality for you. Okay, modulus inequality, most students find it challenging to do. So actually the most straightforward way to solve this kind of inequality is using the graphical method, right? But however, some of students might find graphing difficult, so I'm going to go through this. So firstly, okay, if you just look at what is inside, it is actually a quadratic equation. Then that means we will expect a curve that looks like this or this. But since the coefficient here is a negative number, the coefficient of the x squared is a negative number, so we'll expect a frowning curve, right? And because when x is equals to 0, then we are just left with 3. So that means the graph that we are going to get for 3 minus x squared, just this 3 minus x squared, is going to have the y-intercept at 3, and then it's going to be a frowning curve, sad face curve, right? You know, sad face and smiling face, sad face. This is when negative x squared, this is positive the x squared, right? When the coefficient of x squared is positive, right? So, and what should be here? Alright, if this number is, this x is root 3, then we will have root 3. When we square it, we'll get 3. 3 minus 3 will give us 0. So this is root 3. And this is minus root 3. Note, what I'm drawing is the y equals to 3 minus x squared graph. What about the modulus of this graph? When we modulus a number, a negative number becomes a positive number, right? So imagine all these negative values of y, when we modulus them, it becomes positive. What happens? It is a reflection about the x-axis, so it will look like this. Right? Nope, not this way, but this way. Okay, it will be a reflection of this part on the x-axis, right? My drawing is not exactly accurate, but it should look something like this. Just sketching, right? This is the y equals to 3 minus x squared graph. And what about my 2x graph? Let's change the color. My y equals to 2x graph, when, let's say, when my x is 0, the 2x would becomes 0, right? So it passes through the origin. So, and then I expect it to be steep in some form. So when x is equals to 1, what is my y? It's just 2. I can expect it to be 2, and so on and so forth. So I think, yeah, this is just a rough estimate. I do not know exactly where it cuts, so I just do this for now. Right, no, it should pass through the origin, so I just do this for now. So this is my y equals to 2x graph. Now what is the way to solve inequality using a graph like this, right? Now look at this part again, right? We want the inequality such that this graph modulus 3 minus x squared is greater than 2x, is greater than our 2x. When is this the case? Okay, imagine you see that this graph here, at this part, okay, it means after this point of intersection, this 3 minus x squared graph, the y value of this modulus 3 minus x squared graph is always greater than my y equals to 2x graph. That means it satisfies this inequality. So we want this area. We want this. Between this value and this value here, between this value and this value here, my modulus 3 minus x squared graph is below my 2x graph. That means the y values of this modulus 3 minus x squared graph is smaller than the y values of this 2x graph. So we do not want this part. We do not want the x values for this part. Right? We do not want them. How about for this part? How about from this point onwards and below? Right? Below this value. For below this value, my modulus 3 minus x squared graph is greater than my 2x graph, and which is satisfy this inequality. So we want the x values here in this area. Right? So we want, this is the area that we want. Therefore, what is our solution? We need to find what is the x value here and the x value here. Then we will be able to know what is our solution. But how to find this intersection point between this line and this line? We just solve this equation. Y equals to 2x. No? We just solve this equation. 2x equals to minus 3 minus x squared. Now you may be wondering why I put a minus here. Remember, if this is the 3 minus x squared graph, if we had the 3 minus x squared graph, it would be following the trace of my pen. You see, it would be this. But realize this modulus has reflected this part upwards. So when you add a negative sign, it has the effect of, when the negative value here, for example, when it's multiplied by a negative sign, negative, it goes up there, right? So it has the effect of reflecting this part of the graph upwards. So this graph and this graph here, this part and this part of the graph here actually corresponds to this equation. So I'm trying to find the intersection point here by equating 2x, this line, to minus 3 minus x squared. So if I solve this equation, I get this x coordinate, and I will get this x coordinate as well, because these are the 2 points where this line, no, actually I won't get this coordinate, I'll just get this coordinate, because this is the minus bracket 3 minus x squared graph, this part, right? This part is not. This part is the 3 minus x squared graph, so I will solve it separately. So I will just get this intersection point. I correct myself, I'll just get this intersection point when I solve this equation. So let's see what happens. So we have minus 3 plus x squared, and this 2x I bring over, so it becomes minus 2x, then equals to 0. Right. And so how do I solve this? This one, basically I just be x minus 3 x plus 1 equals to 0. How do I know this one? This is your secondary school math. So this x squared, so you have x and x, right? Multiplying these two give you x squared, and minus 2x comes from here, right? So, and minus 3 comes from here. So I need to multiply two numbers to get this number. So one of them is minus 3 and one of them is plus 1. How do I know? Because now you're going to multiply or cross multiply. So x minus 3, x times minus 3 get minus 3x, x times 1 give you x. So we make sure this part is satisfied as well. X minus 3x give me minus 2x. So if everything is satisfied, so you see this x plus 1, x minus 3 come from here. So this one, if we expand out, we get back to this one. And this tells us that either our x is equals to 3 or our x is equals to minus 1. So either of these solution will result in the whole thing becoming 0. So this is our solution. So could this be minus 1? No, it wouldn't be minus 1, because this side is positive. Could this be? So the number here should be 3. The number here should be 3. So one of my solution here, because I want the area, the x in this region, so this part is one of the inequality I found is x greater or equals to 3. No, don't have the greater sign, because don't have the equal sign below because there's no equal sign here. So we follow it. There's no equal sign here, so there's no equal sign here, right? Then we also, another region that we want is from here smaller than this number, right? Correct. So we have to find this intersection point. How do we find this intersection point? Since this part follow the formula, follow the equation 3 minus x squared. So I will find this by taking 3 minus x squared equals to 2x. So the point where this y equals 2x line intersect with this 3 minus x squared line is this point. So if I solve for this, I get the x. That is the x coordinate of this intersection point. So I have x squared plus 2x, because I'm bringing this x squared over and this 3 over, so you come minus 3 and equals to 0. So from here, because now I let it be x plus 3 and x minus 1, because I know that 3 times x will give me 3x and x times minus 1 will give me minus x. So 3x minus x will give me this 2x. X times x will give me x squared, and 3 times minus 1 will give me minus 3. Okay, so this one. So from here I'll get two solutions. One of them is x equals to minus 3 and the other is x equals to 1. And obviously this one is not this x coordinate because it's negative. Should be 1. Because this is the part of the axis that is positive. So this point here is 1. Okay, so that means my other inequality here is x smaller than 1. Alright, what happens if I include the equal sign? If I include the equal sign 3 here, I will get 0. 0 greater than 6 is no, 3 minus 6, no. So if I include the equal sign here, 3, 3, 9, not 3 minus 9 will give me minus 6. Minus 6 modulus will give me 6. And substitute 3, 3, 2, 6. Both sides will be 6. But 6 is not greater than 6. 6 is equal to 6. So I cannot include the equal sign below. Right. So basically this is my solution. Now is there other methods for finding this? Yeah, surely there is. So this one, x greater than 3 and x smaller than 1. So let's go to do the other method, commonly called the algebraic method, for finding solving this inequality. Should give us the same solution. So now we know that when x greater than a, is imply x greater than a and x smaller than minus a. Right, when x smaller than a, this implies x is between minus a and a. Does it apply here? So what if I say, okay, now actually not. Okay, we have to separate this into two cases. So between when x is between minus square root minus 3 and minus square root 3 and square root 3, when x is between minus square root 3 and square root 3, this curve is 3 minus x squared. Alright, we want it to be greater than 2x, correct? So we need to try to solve. And the other side, when x is smaller than minus root 3 or x greater than root 3, it means greater than this point. No, yeah, greater than root 3 from here onwards. We want the graph which is minus 3 minus x squared, because that's the reflected part of this graph here. So we want this to be greater than 2x. Still, we want it to be greater than the 2x graph. We want to find where it happens, right? Then this part, when we do, we bring over, so x squared plus 2x, or x squared plus 2x minus 3. Remember, then we are at the smaller side, so smaller than 0. Okay, so for this part, we will be broken down to x plus 3 factorized and x minus 1 smaller than 0. Okay, so the next thing is using a number line, minus 3, 1. Minus 3 come from this factor, and 1 come from this factor. So here, but note, we also have this constraint over here. So between, we also need to put this minus root 3, we know is here. Root 3 is more than 1, so root 3 is here. So we only take the overlapping part. Alright, so we only take the constraints here. So this part, okay, how do we check for, how do we do this? Alright, okay, so I must look at this part. For example, this is, I choose a number that is minus 4, for example. If I choose minus 4, then this minus 4 substitute inside. Minus 4 plus 3 is negative 1, it's a negative number. Negative number minus 4 minus 1 is also minus 5, is a negative number. Negative number multiplied by a negative number is a positive number. So I mark this region as positive. So any negative number that's smaller than minus 3, I substitute into this thing, I will get a positive number. So any number greater than 1, if I substitute, let's say for example 2, if I substitute inside, I will get a positive number. And any number between minus 3 and 1, between these two numbers, if I substitute inside, I will get a negative number. You can try. You can, for example, you can try 0. When you try 0, 0 is between minus 3 and 1. When you try 0, this will be positive, this will be negative, and that I get a negative. So because our equation, we want it to be smaller than 0, therefore we choose the negative region. If it's greater than 0, then we choose the positive region, but now it's smaller than 0, so we want this negative region. Alright, but can we take all of this negative region? Actually, we can't. We can only take is between minus root 3 and root 3, right? Because this equation only describes the graph between minus root 3 and root 3. It doesn't describe the area here. It doesn't describe the area beyond. So the only part, the inequality that we actually really want is just this part. So the overlapping part, so just this part. Okay, from here to here, right? So the inequality that we get from here is this: x greater than equals to minus root 3 and smaller or equals, do we include 1? Do we include 1? No, we don't. Reason we don't include 1 is same as because we are not including 0 here, so we cannot include 1 here, because once you include 1 here, we get 0, which is not what we want. But can we include minus root 3? If you include minus root 3, yes, the number is still smaller than 0. And between minus root 3 and root 3, the equation is defined as this one. So we want that. Right, so how about for this part? So now we are looking at x smaller than minus root 3, that means this area of the graph, and x greater than root 3, so this part of the graph. Now, okay, so we solve for this equation first. So this, we solve for this equation. Never mind, where's my black color black color pen? Yep, it's here. So this one would be minus, no, right, I'll just bring it in straight. So minus x squared, so I'll get x squared. X squared minus 2x, this 2x I bring over, and minus 3, then I'll be greater than 0. So just check x squared minus 3 minus 2x. Right, so because I want a negative 2, so I'll put the negative on the 3. Negative 3x plus x will give me negative 2x, so greater than 0. So now I use the number line again. This one, minus 1 came from here and 3 came from here. Right, and now okay, let's choose a 0. 0 is between minus 1 and 3. I substitute inside. This is a negative number, this is a positive number. So negative times positive overall is a negative number. So the other regions are just positive because, right, one quick way of saying is that you look at the power of this factor. Let's say the power of this factor is odd when you passes through that region, where this one, the first region that you determine to be negative. So if this is an odd power when you passes through this 3, it should alternate when this is odd power. Let's say if it's even power like 2 or 4, then when it passes through this factor, it will remain as the same sign. That means it will negative, negative, right, in that case. But now all of these brackets have odd powers. All of these factors has odd powers, so the region will alternate in sign. Okay, so because we want the inequality to be greater than 0, so we will go and we take the positive region. So that's for our inequality could be greater than 3 and smaller than minus 1. But take note, because we only want the part that is greater than root 3 and smaller than minus root 3. So let's see what happens here. So because we want it to be smaller than minus root 3 is smaller than minus 1, so that means we only take from here. Alright, and here we want it to be greater than root 3. Root 3 is smaller than 3. So this is root 3 and I want to take it from here. So we only take the overlapping region. Alright, and this point we are also not including. Right, this point we are not including because we are not including 0. This point we are not including. So therefore, the part that we want is this overlapping region with this overlapping region. Of course, the black includes this as well, include this part as well. Right, so the inequality as a result that we get is x greater than 3 and what? And x smaller than minus root 3. Only the overlapping part. So if we combine with our earlier inequality here, so what do we get? This inequality, the first inequality tells us that x should be greater or equals to minus root 3 and smaller than 1. The second inequality tells us that x should be greater than 3 and also smaller than minus root 3. So this is, finally we know that, okay, this is the union of all this is our answer. So x smaller than 1 all the way, including minus root 3 and smaller. So one of the inequality here is x smaller than 1. And the other inequality here is x greater than 3, which is the same as the answer that we have gotten earlier. So some of you might ask, why aren't we using just the overlapping regions? No, because you have to understand this nature of the graph here. Both of these parts satisfy the inequality here. So if this is confusing for you for modulus, inequality involving modulus, I would suggest that you just stick to using the graphical solution. I think that's the most effective. Somehow this algebraic method is a bit, I find it very confusing for like beginners, right? So if learn your graphing and try to practice using graphing. So that's all for today.